Hi Spring fans! In today's installment of Spring Tips, we're going to look at the Java Object-Oriented Query API, which makes it dead simple to work with an underlying SQL-based database using a typesafe Java API. So we're going to use jOOQ. There's an auto configuration for jOOQ inside of Spring Boot itself, even though jOOQ, of course, is a third-party project which originated from Lucas Eder. We're going to use H2, which is an in-memory database, but we're not going to actually use it embedded. We're going to talk to a server mode installation of H2. And then we're going to use Lombok just to make short work of generating our details here. And we've got the database here. We've got an actual H2 database running on the local machine. I'll log in here. And you can see I've got two tables. One's a customer, one's a product. The relationship is that there's one customer and multiple 0 or n products. So we could, in our persistence here, in our ORM layer, in our mapper layer, select every customer, and then for each customer do a select all from products where the customer ID in the product table equals the customer that we're looking for. That would create the n+1 problem that we want to avoid. That is so typical of higher level ORM tools that don't give you enough control. We could do that. We could also just select all from customer, select all from product, possibly with some sort of predicate, and then match them, correlate them both in client memory. That would certainly work. But it's much more efficient just to select them all, select them all, select the joined result of all of them, and then inside client memory do some pre-processing or processing to extract the records as we expect. So let's see what that query would look like. Let's say select all from customer C, left join product P on C dot ID equals P dot customer ID. If we do that search, we see that we have well, first of all, we have the customer information. That seems to be redundant here, right? But we've got, for example, 4 records for customer 1 because we have 4 products that have that foreign key, right? So different products here, and then seemingly redundant customer information. So we want to group by the customer when we do this query. We want to be able to group by the customer as the key, and then iterate over the product. We could do an inner join, right? I'm using a left outer join here. But if I do an inner join just like this, the problem is that the customers that have 0 products, no entries in the table to match them, they don't appear. Right? So we want to avoid that. We want to make sure that even if there are 0 products, we still get the customer information. So I'm doing a left outer join to avoid that particular situation. Because of that, we have some records that have nulls. We need to be able to care for that when we map into our Java object graph. All right, so now going back to our example here, open this up in our IDE. All right, we have a new Spring Boot application. It's pretty typical. We'll start writing code here in a minute, but what we need first before we can go anywhere is to let jOOQ generate or reverse engineer our schema, our database schema, and generate type-safe objects that we can use to sort of represent the fields, the columns, the structure of the tables in the database in nice, crisp Java objects. So that requires a bit of build time configuration, right? Build level configuration. We've got a plugin here for Spring Boot. We need to bring in a fair bit of other things as well. So the first thing we need to do is to configure the jOOQ code generation plugin, and that in turn is going to need information about our data source. We want to get that information centralized, right? I don't want to have development credentials in the build file as well as in my Spring Boot application, which of course is going to have a data source that will connect to our H2. So let's also teach our Maven build to draw Maven project properties from the same place as Spring Boot does, application.properties. I've got this stuff written out already, so I'll just borrow that. Okay. And here we go. There we go. So what we've got here is one too many plugin elements, certainly. So there we are. That should be. There we go. So what we have is we have the Spring Boot plugin up here. Actually, that's redundant now. It appears I already had it, so I'll get rid of that. We have a plugin here which will add the generated output from the jOOQ plugin to the source directories that Maven will respect when it compiles the code. We have the Spring Boot plugin itself. And then under a separate Maven profile, that is to say, you have to activate it by specifying -p and then the name of the profile, in this case, generate. In a separate profile, we have two plugins of interest. The first is to teach our Maven build to source some properties from a property file as opposed to just these properties, these sections. So we'll be able to use and interpose the properties and resolve them from the property file, just like we would in a Spring application context or Spring configuration class. In fact, the syntax is the same, right? Which I think is convenient. So that implies that we also need the CodeGen plugin, right? So that's all configured here. We're depending on H2 the database. We've got a client-side driver here, and we're using H2. Now it's important to know that jOOQ is open source for open source databases, but for the express editions of the commercial databases, there's a certain license, and then for the production versions of the commercial databases, there's a different license altogether. All of which are very reasonable, but we're using H2. It's open source, so we can get away with using the open source bits. Let's see. So we need to actually configure the data source information for our Spring Boot application. So we say data source driver class name. We're going to use H2. Data source password equals SA. Username equals SA. And finally, the URL is what we had here in our H2 console. Let's grab that. There we are. I want to tell jOOQ about the dialect it should use when talking to our database. In this case, it'll be H2. Though you can see that a good many other options are well supported. And then I want to also turn on logging, right, for the jOOQ types in particular, because there's some really useful stuff that we get if we enable that. So org.jOOQ.tools equals debug. All right. Now let's put this all to work. cd jOOQ maven package -p generate. Good. So if everything's gone to plan, we should have a generated folder. There we are. And we import the Maven project so that IntelliJ is aware of the new source directory, source tree. Maven re-import. Okay, and there we go. Now we have full access to the API. Now I'm going to show you how to create a simple repository method to interact with the database. We're going to create a customer repository, and we'll read some data from the database. But it's worth knowing how to create data. In this case, we've already got data, so I'm not going to actually run this code, but it's worth knowing how to do it. Let's suppose I had a post construct method here, public void init. Actually, we could even just have a save functionality, right? So we can make this repository transactional. The auto configuration for jOOQ is automatically it'll automatically play well with Spring's platform transaction manager abstraction. So we can just make the bean transactional. We can say public void save, and then what are we going to save? Well, we can say string email, right, for a customer. I guess that would be a very simple customer that could work. We might even be able to pass in a collection of product, but for now, just trying to show you how to get one method to work. By the way, all methods in a component that is annotated with that transactional are in turn transactional, so we don't need to re-specify it there. What we want to do is we want to save that record. In order to do that, we need to inject the jOOQ DSL context, right? So the DSL context is the centerpiece of the API. It's the heart, if you will. It's the thing. It's like the Hibernate Session API, or the Entity Manager in JPA, or the MyBetas Mapper. It's how you start working with the API, and the API from there is very, very fluid, as it's supposed to be. So I'm going to say insert into customer. Okay. Dot columns, and the customer the columns that we care about are customer.customer dot email dot values, and here we're going to specify value. Right, so there's that value. Now, there's lots of other options here. You can use the DSL context to actually batch commands and then run them all at the same time. But either way, it's atomic. If you do multiple statements within this save method, for example, and then something goes wrong, if you throw an exception at the very last line, the whole unit of work will get rolled back because it is transactional, right? So that's how you write, but in our case, that's not the sort of thing we're going to do here today. Let's take a look at what it would be like to query or select all the customers. So insert customer. I'm going to create a new method here, public collection of, and of course the question is, what do we want to map it to, right? jOOQ doesn't give us an ORM. It's not a model-driven development kind of thing. It's not going to give us a Java class for our domain. It's going to give us a Java class that we can use to interact with the tables for that, the table elements for that table. So what we need is a client-side representation, or DTO here. So I'm going to say customer DTO. I'll have another class product DTO, and we're going to make these a Lombok no args constructor, all args constructor. So that'll just, it'll give us some constructors, a toString method, equals, all that stuff, getters and setters for all the things we create. So I'm going to say private long ID, private string SKU, private customer DTO customer, and we want to make sure that the toString on this entity doesn't include the customer, because the customer will in turn have all the products, which will in turn have all the customers, which will in turn have all the products, etc., etc., etc. So it'll recursively try and render itself, and we'll get nowhere. So we're going to exclude that. Now, we also want to make sure that we have customer information, so private string email, private long ID, and of course a collection of product DTOs, which will make a hash set. There we are. So now, let's look at returning or querying or interacting with all the customers. Okay, so select all customers. And what we want to do is use the DSL context. We're going to say this.dsl context.select from customer left join product on product dot customer ID dot equals customer dot ID right? And it doesn't really matter, but it's cleaner. I always find it makes it a little cleaner to do the thing. So let me fix that. Okay. And then, having done that join, we want to fetch the data, the resulting data, into groups by a certain key, right? So we're going to say group all the records and create a map for us. The key will be the data from the records that matches what we're going to specify here, and the values will be a collection of one to more values that match that key. Rather, it's going to be all the rows that match that key. So it'll be ideal for our particular situation. We're going to have a map whose keys are the customer IDs, and then whose values are the rest of the records, which we can then assume are the one or more products. Okay, so we're going to say into groups customer dot ID customer dot fields. All right, and that'll do. Actually, that'll give us a map as we expect. So let's undo that. Return this. Okay. There we are. So there's our resulting data. Now, what we have here, as I say, is a record for the customer information, and then a bunch of records that match that. So now we can iterate through that and build our object graph up one by one, right? So we can say return record result map dot values, and I'm going to stream over them, and then I'm going to map every single record into our object graph. Right? So we're going to create a list here, and the list, of course, is indeterminate. It doesn't know what type it is until we actually return something of that type. So let's see, customer DTL equals r dot into customer ID, customer email, into customer DTO dot class. Okay, and what do we have here? Oh, right, we need to get the first result. We have multiples here. So, okay, that's the customer DTO. And notice how we don't have to actually unpack it. I mean, we could if we wanted to, but jOOQ provides this handy into mechanism where you can say, give me these fields, and then interpose them on a DTO of this type or a POJO of this type. It'll even honor JPA at column annotations if you have, for example, to correctly map the fields that it's extracting to an object that we have. In this case, it's even smart enough to see that we've got a constructor and to try and use the constructor that'll match and so on in the field. So you get a lot of leverage out of this arrangement. And now we want to get the products. And remember, we have a record. What we want to say is sort ascending customer dot ID dot into, and we want to say give us a product DTO dot class. Okay, so when we do that, we're given that type, we're given a list of product details. We might have a list with one object in it that has nulls. So we want to say only give us that if we can guarantee that it's not useless, right? So get ID does not equal null dot collect into a list, right? So basic functional program. So now we have an empty list if there's nothing there, or we have however many products that are in that, and we have the customer DTO. What we want to do is make sure that we can build up our object here. We could do this. We could say actually into customer DTO, or we could just say give me the values, right? So value 1, values row, gives me the row. The long customer ID equals values row dot value left first field 1. There we go. So value 1. Values. Oh, right, there we go. That's what we want. So we want this thing here to be dereferenceable. We're going to manually unpack the record. So record 2, and then we'll say record 2 dot value 1 is the customer ID, and I'll say that the email is record 2 dot value 2. So again, notice how we've got these very nice typed APIs. We've got an effective tuple. This isn't just a var args type underneath. It's actually, the jOOQ API has so many permutations of records that have generic parameters up to like 20 different elements. Right? So you have a table with 20 different elements. You can use typed APIs and it's aware of the typing. Value 2 is generically typed to string because it knows that this was a string. Right? So that's very, very convenient. We're getting a record 2 instance there, right? That's what that means. So now we've got that, we've got the product details. Now we can build up our customer. So return new customer DTO, passing in the customer ID, passing in the email, and the product details, and voila. Okay, so there's our simple mapping. Not so bad, I think. Pretty straightforward. And what's happening is, if you understand SQL, this is very easy to run, and very easy to understand. But there's not two different domains here, right? It's just nice, clean, type-safe code. So it makes it much easier to debug and to iterate through and to understand. And let's see if it works. So in order to prove it works, we need to take advantage of our new repository here. We'll build a command line runner, which will get invoked when the application starts up, and we'll inject our repository. We'll say that we want to select all customers .for each, and we'll tell it to just call the printline method for every record received or received. Okay, so let's go ahead and start the application up and see what we get. Oh, would you look at that? We have on the console here customer DTO 1, and there's an array of product with multiple products inside of it. Customer DTO 2, 3, 4, 5 with nothing in it, 6, 7, and 8 with nothing in it. And if we go back to our actual table here and run the same query again, which by the way we don't have to duplicate because it's been helpfully logged for us on the console along with the parameters that we've specified if we ran, for example, an insert. Okay. So there we go. So there we can see we have 4 customers starting from 5, 6, 7, and 8. Starting with IDs 5, 6, 7, and 8 that have no product, and that's been reflected here, 5, 6, 7, and 8. So there we have it. We have a very simple jOOQ application. You can see that jOOQ makes working with your underlying SQL database a breeze. It gives you the full power of your underlying SQL database, which is really the selling point here. If you have a SQL database, it's silly to object relational mismatch, impede yourself away from all the power of that underlying SQL database. Take full advantage of it. And if you're not interested in stringly typed programming and having strings and concatenation statements all around your code base, that's fine. jOOQ is a great fit for that and gives you the full power. With that, thanks for tuning in, and we'll see you next time.